Dear students, we are handling the topic complex numbers objective. Level 2 classwork is going on. In previous class, we have discussed until 4 questions. Today, starting question from 5. If a plus ib plus ci square plus di cube, if a plus ib plus ci square, a plus ib plus ci square plus di cube, a plus ib plus ci square plus di cube is equal to x plus iy whole square, then root of a minus ib plus ci square, root of a minus ib plus ci square minus di cube is equal to dash. Here write like this: a minus ib plus ci square, meaning I square value minus 1. So minus c you write, plus di cube. I cube is equal to I square into I. So minus 1 into I. So minus I. So minus id. Minus id is equal to x plus iy whole square. So this can be written as x square minus y square plus 2ixy. That implies a minus c within brackets plus minus I taken common, minus I, not minus I, simply plus I into b minus d is equal to x square minus y square plus I into 2xy. Now comparing real comma imaginary parts. Comparing real comma imaginary parts. Comparing real comma imaginary parts, you are getting a minus c is equal to x square minus y square, and b minus d is equal to, this is comma, b minus d is equal to 2xy. Now what he is asking? A minus ib plus a square minus di cube. Now over root of a minus c, a minus ib, let us write here a minus c, because I square is equal to minus 1, a minus c, minus I taken common becomes within brackets, this is ib minus, writing like this, this is a minus ib minus c, minus I cube becomes I cube, meaning I square into minus I square into I. So minus 1 into I, it is minus I, minus of minus plus is there, so it is id. I cube is equal to minus I, so it becomes plus id. So minus taken common. Now write here minus I into b minus d. That now which we should calculate this one. Instead of a minus c, you write here x square minus y square minus I into b minus d. So b minus d becomes minus 2xy into I. This can be understood as x square minus 2I into xy plus I square y square. This is I square y square. So write like this: x minus iy whole square. X minus iy whole square. Therefore, now we need to calculate the value whatever he given in root. Root of a minus ib plus ci square minus di cube is equal to simply x minus iy. X minus iy is the answer. Third option. Now sixth question. Sixth question. Let Z is a complex number. A is equal to modulus of x plus modulus of y. A is equal to modulus of x plus modulus of y, and B is equal to root 2 into modulus of x plus iy. B is equal to root 2 into modulus of x plus iy, and which of the following is true? So better to put shortcut. Put x is equal to 1, y equal to 1. That implies A becomes modulus of 1 plus 1 becomes 2. So A is equal to 2 and B is equal to root 2 into this is of course nothing but 1 plus I. So root 2 into this is root 2. So A is equal to B. Root 2 into if it is less than, if it is 0 and 1, of course it is also root 2. So according to is equal to number only for first option is there. Option 1 verified. Seventh one already completed. I said the formula 1 by e power r sin theta completed in the conceptual teaching. Now eighth one, z cube. If iz cube plus z square minus z plus I is equal to 0. iz cube plus z square minus z plus I is equal to 0, then what is the modulus of z? That implies what is the modulus of z? Given iz cube plus I, right side beside, iz cube plus I plus z square minus z equal to 0. So I taken common, z cube plus 1 plus z square minus z is equal to 0. 0 plus I you can write. So compare real and imaginary part. Compare real comma imaginary parts. So z cube plus 1 equal to 0. No, z cube plus 1 equal to 1. And z square minus z is equal to 0. So z cube is equal to 0. Z cube is equal to 0 and z square minus z also equal to 0. So in this case z equal to 0. If we take common here, z minus 1 equal to 0. So in this case z equal to 0 comma z is equal to 1. If we given the condition z not equal to 0, of course you should not use 0 option is not there. So that is why you should not consider z is equal to 0. So z is equal to 1 you consider whenever z is equal to 1 modulus z also 1 for the complex number. So it is first option. Now ninth question. Z1, Z2 are roots of equation. Given quadratic equation in complex numbers given as z square minus az plus a square is equal to 0. Z square minus az plus a square is equal to 0. Then find modulus of Z1 by Z2. According to 1 plus omega square is equal to 0, let Z is equal to minus a omega here. Let Z is equal to, Z1. Z1 is equal to minus a omega and Z2 is equal to minus a omega square. Try to understand that minus a omega and minus a omega square are roots here. So minus a omega whole square minus a into minus a omega plus a square. I am verifying whether it is root or not. Now you can understand here a square omega square. A square omega square plus this is a square omega plus a square. Of course it is 0 whenever you are taking a square as common. So Z1 is equal to minus a omega. Z2 is equal to minus A omega square, confirm. Now what he is asking, Z1 by Z2 over modulus. Modulus of Z1 by Z2, we learnt the formula modulus of Z1 by modulus of Z2 separately. So modulus of minus A omega by modulus of A omega square. Minus A get cancelled. So modulus of omega by modulus of omega square. I mean modulus of omega meaning here minus 1 plus I root 3 by 2 over modulus, and minus 1 minus I root 3 by 2 over modulus. So 1 plus I root 3 by 2. So this is root of 1 by 4 plus 3 by 4 over root by. This is also root of 1 by 4 plus 3 by 4, that is equal to 1. So modulus of Z1 by Z2 is equal to 1. Now 10th question. Tenth question. If Z is a complex number such that modulus of Z greater than or equal to 2, then minimum value of modulus of Z plus 1 by 2. Modulus of Z greater than or equal to 2. Then you need to calculate minimum value. Minimum value of modulus of Z plus 1 by 2. Minimum value of modulus of Z plus 1 by 2. Given 2 less than or equal to modulus Z. Of course, mod Z greater than or equal to 2. Less than or equal to, add like this, Z plus 1 by 2 minus 1 by 2. Z plus 1 by 2 minus 1 by 2. So this is according to squared inequality. This can be understood as Z plus 1 by 2 plus 1 by 2 separate. That implies if you write 2 minus 1 by 2, this one, less than or equal to Z plus 1 by 2. So 2 minus 1 by 2 becomes 3 by 2. 3 by 2 less than or equal to modulus of Z plus 1 by 2. That's all. Therefore, modulus of Z plus 1 by 2 greater than or equal to 3 by 2. So minimum value of modulus of Z plus 1 by 2 is 3 by 2. So that 3 by 2 according to option it's lie between 1 and 2, because the minimum value is equal to 3 by 2, 1 by between 1 comma 2 the 3 by 2 exists, lies between, you can write, lies between 1 comma 2. Only Z greater than or equal to 2 he given, so the value of Z minimum value is 2 according to option. Below 2 and until 3 by 2 only 4th option is there. Now let us going to discuss about 11th question. The range of, if modulus of Z minus 1, modulus of Z minus 1 plus Z plus 3 less than or equal to 8, range of values of modulus of Z minus 4, range of values of modulus of Z minus 4. Concept I am writing. This is the concept of PA plus PB less than or equal to 2A. I mean less than or equal to K. Or for ellipse, which you will learn in detail in mathematics 2b concept for ellipse. SP plus S dash P is equal to 2a concept. So draw the ellipse like this. If it is 1, it is general ellipse. If it is I, it is reverted ellipse. Already we discussed in examples, solved examples. Draw like this. Put here, this is A, this is A dash. This is any point P on the ellipse. This is S and S dash are two fixed points. They are called as foci or foci. S is equal to here Z minus 1 is there. So Z minus 1 I am writing. Z minus 1 over modulus plus Z plus 3 over modulus less than or equal to 8. So here you can able to understand this one as x minus 1 plus iy over modulus plus x plus 3 plus iy over modulus less than or equal to 8. This locus is called as on the and below the boundary of the ellipse. So here you can understand S is equal to 1, 0. This is called as fixed point focus. Now S dash another fixed point is minus 3, 0. If it is any I term is there, I into y minus 1 like that, you can write here 1. If I into y minus 2 like that is there, you can write here by minus 2 like this. If it is nothing is there other than I y only, then you should write 0. S is equal to 1, 0. These are fixed points. And S dash we got minus 3, 0. It's okay. Now C meaning always midpoint of the foci. C is equal to, the concept is midpoint of constant terms, fixed points. So 1 minus 3 by 2. 1 minus 3 by 2 becomes minus 2 by 2. So you can write center as minus 1, 0. Center as minus 1, 0. General notation of ellipse I am discussing. If C is equal to center h, k, h plus center h, k, then A and A dash are vertices. A can be say that h plus A, k, and A dash can be say that h minus, h plus or minus A, k. Yeah, h minus A, k. So what is k here? Of course, because it is on x-axis, everything is 0. Y coordinate is 0. Now, since h, k is minus 1, 0. Yes, I am discussing to you that S meaning h plus A, k, and S dash another focus is h minus A, k. Now A is equal to h, k we got. So what is A? C is equal to h, k. A is equal to h plus A, k. What is A? SP plus S dash P is equal to 2A formula is there. So what is SP plus S dash P? SP, the locus here he given as SP plus S dash P is equal to 8. So 2A is 8. Therefore you can understand A is equal to 4. Now depends upon this one. HK is equal to minus 1, 0. HK is equal to minus 1, 0. A is equal to what I said? H plus A, k. So minus 1 plus 4, 0. Minus 1 plus 4, 0. A dash is equal to minus 1 minus 4, 0. So at A you can write here 3, 0. And at A dash you can write minus 5, 0. Now he is asking that A dash we got. PA plus B less than K, SP plus S. Value of modulus of Z. Here P of Z, that is x plus iy or x, yb, any point. Now we need to calculate modulus of Z minus 4. So if P is any point here, maybe here x, y, modulus of Z minus 4. So the range he is asking. The range he is asking that modulus of Z minus 4. So options, according to option 0 should not be there because z minus 4 may be there. 0 you should not get the value. Two options are there. So here if p is modulus of z minus 4, is there. Total distance a dash is equal to 3 plus 5, it is 8. So many options are there, depends upon 8. 0 should not be there. Minus 5 comma 0 we got, 3 comma 0 we got, a dash everything okay. P z be any point and q is equal to 4 comma 0 is given. This is 3 comma 0. So this is SP plus S dash P concept. So the distance minus total distance is 3 plus 5, it is 8. And 8 minus 4, this is 3 plus 1, 4. Q4 comma 0 he is discussing this. For complex number he is asking range. Then range of the values of z minus 4. So what is z we need to calculate. Z is equal to x plus I by. So according to this one, the z is equal to x plus I by. So distance from, if we take center, of course here everything is okay. Now to calculate, to find out I am writing, to find out. To find out modulus of z minus 4. So what is z here? If you take, okay, the points, let us read the question carefully. Then the range of the values of modulus of z minus 4 lesser than or equal to 8. So minimum value that should be on the ellipse, this is 8 and this is B like this. Now you can understand range, to find out range of this one, modulus of z minus 4. So you can write here the range meaning last point, the minimum, of course this is maximum value minus 5, even though minus 5 is there, this is the greatest distance. So you can write minus 5 minus 4. Try to understand that the point, whatever the point is there on the ellipse, it is minus 5. And you can write minus 5 minus 4 comma minus 5, not minus 5, 3 minus 4. 3 minus 4. It is called as minimum and maximum distance on the of any of the point on the ellipse. The formula is a plus ex1 comma a minus ex1. You will be learning in the ellipse chapter. Now you remember as a formula whatever the maximum distance of the point is there on the ellipse and whatever the small point, minimum distance of the point. So the distance for 4 and 3, distance for 4 and minus 5 you need to calculate. So now minus 5 minus 4 becomes, this is 9 and this is 1. So range always you should write with a small number. So range is equal to 1 comma 9. The formula is a minus ex1. So E means eccentricity. Here he did not give. So of course eccentricity we can calculate using A is equal to, this is AE is equal to 1 and AE is equal to 3. So AE is equal to 1 we got. AE is equal to 1 and A is equal to 3. So 1 by 3 is E. Using condition of eccentricity, B square is equal to A square into 1 minus E square. Okay, you discuss later. Depends upon 2B, you can learn it. A minus ex1 comma A plus ex1. It is nothing but small minus whatever the value we are calculating. Small minus big small. And small minus the value and big minus the value. So 3 minus the value 4 and minus 5 minus the value 4 is the range. Now 12th question. complex numbers. For all complex numbers z1 comma z2 such that modulus of z1 is equal to 12. Modulus of z2 minus 3 minus 4i. Modulus of z2 minus 3 minus 4i is equal to 5. Then minimum value of z1 minus z2. Minimum value of z1 minus z2 over modulus. One formula is there. Modulus of z1 minus z2 greater than or equal to modulus of z1 minus modulus of z2 depends upon previous formula. Modulus of z1 minus z2, yes, greater than or equal to modulus of z1 minus modulus of z2. That formula we need to remember now. Modulus of z1 minus z2 greater than or equal to modulus of z1 minus modulus of z2 separately. That implies modulus of z1 minus z2 is asking now. This one you can understand greater than or equal to modulus of z1 meaning of course 12 minus you can write this one. Modulus of z2 minus 3 minus 4i. So adding and subtracting. Plus 3 plus 4i. Plus 3 plus 4i. That is greater than or equal to 12 minus. Write like this. Modulus of z2 minus 3 minus 4i. And in the similar way, this is the concept modulus of z1 plus z2 greater than or equal to concept. So modulus of z1 plus z2 greater than or equal to concept. This meaning is plus 5. So this is 5 he given. So minus of total you write here. Minus of this meaning over modulus 5. So I am writing here modulus of, again used concept here. Modulus of z1 plus z2 less than or equal to modulus z1 plus modulus z2 like this. So this one like separately I have calculated. That implies modulus of z1 minus z2 greater than or equal to, this is 12 minus, this is 5 he given. So within the brackets this is 5 plus 5. So modulus of z1 minus z2 greater than or equal to 12 minus 10. 12 minus 10 gives 2. That's all. So 2 is the least value. Yeah. Minimum value meaning 2. Now 13th question. One, the range of the real number alpha. Range of the real number alpha such that the equation z plus alpha into modulus of z minus 1. Z plus alpha into modulus of z minus 1. Z plus alpha into modulus of z minus 1 plus 2i equal to 0. Where z is equal to x plus iy. He is asking range of alpha. So we should convert the complex number into quadratic equation. So here write x plus iy plus alpha into, this can be written as x minus 1 plus iy over modulus plus 2i equal to 0. That implies x plus I taken common, I into y plus 2. X plus I into y plus 2 plus alpha into modulus meaning root of x minus 1 whole square plus y square is equal to 0. That implies x plus I into y plus 2 is equal to minus of alpha into root of x minus 1 whole square plus y square That implies what he is asking, the range of real number alpha. So alpha, in the terms of quadratic equation alpha we should get. So x is equal to x plus I went like this. So better to take like this, I into 0. I into 0. So compare real comma imaginary parts. Compare real comma imaginary parts. That implies the full value x we got like this. X is equal to minus alpha into x minus 1 whole square plus y square. If we squaring on both sides, we can write here x square is equal to alpha square into x square minus 2x plus 1 plus y square. And by comparing here imaginary part, you can understand here y plus 2 equal to 0. So y is equal to minus 2. Substitute here y is equal to minus 2. So x square is equal to alpha square into x square minus 2x plus 1 plus 5. No, it is 4. It is 4. So we are preparing the quadratic equation. Alpha square into x square minus 1. He is asking the range of alpha. So alpha square into x square minus 1 minus x into, I am writing within the brackets, 2 alpha square, x into 2 alpha square. Next one plus alpha square, 1 alpha square, plus instead of y is equal to minus 2. Of course here alpha is there, we should substitute for this one also like this, like this. So this is alpha square plus 4 alpha square becomes 5 alpha square, plus this is 5 alpha square. 5 alpha square is equal to 0. This is a QE in alpha, of course. Okay. This is a QE in alpha. So better to write x square minus, better to write x square minus, not like this. X square minus 1 into alpha square. X square taken common. Within the brackets alpha square minus 1. X square minus 1 within the brackets alpha square minus 1. So this is QE in x. If it is real or it is defined. What he is saying, if it has a solution or if it is defined, it has a solution. If it has a solution, if the quadratic equation has a solution, we got into real parts. If it has a solution. So the complex numbers we have converted into the real values of a quadratic equation. If it is defining that it has a solution, that implies delta greater than or equal to 0. For real I am discussing with you. So real formula b square minus 4ac. So 4 alpha power of 4 minus 4 into alpha square into 5 alpha square. 4 into 5 greater than or equal to 0. So with 4 you divide. No, this is x square minus an alpha square. It is not correct. Alpha square into x square minus 1. Alpha square. Alpha square into x square minus 1. Minus alpha into 2x. 2x alpha square. Full for everything alpha square into 2x alpha square. For everything alpha square you can take on alpha 2x alpha square plus 5 alpha square. 5 alpha square equal to 0. Take alpha square common. So if we take x square alpha square, if we take equation as x square, multiply like this, x square alpha square minus alpha square minus x into 2 alpha square, yeah, plus 5 alpha square equal to 0. Taking as x square common, alpha square minus x into 2 alpha square, this is x into 2 alpha square plus 4 alpha square equal to 0. Use delta greater than or equal to 0. So b square minus 4ac concept, b square minus 4ac meaning 4 alpha power 4, this is 2 alpha square. 4 alpha power 4 minus 4 into 4 this is 5 alpha square. 4 into 5 this is 20 alpha square. You are getting wrong. We need to calculate the range of alpha. So alpha belongs to, like you should get b square minus 4ac concept. Otherwise minus b plus or minus alpha square minus 1 into x square. Alpha square minus 1 into x square minus 2x alpha square plus 5 alpha square equal to 0 has a solution. Once again we can do from here. X square is equal to alpha square x square minus 2x alpha square plus alpha square plus 4 alpha square equal to 0. X square alpha square minus 2x alpha square plus 5 alpha square equal to 0. Alpha square into here x square alpha square minus x square. Alpha square taken common, x square taken common, alpha square minus 1. X square taken common, it is alpha square minus 1 minus x into 2 alpha square plus 5 alphas equal to 0. Use delta greater than or equal to 0 for the equation. So delta meaning b square minus 4ac, 4 alpha power 4 minus 4 into alpha square minus 1 into 5 alpha square greater than or equal to 0. That implies divide with 4. It becomes alpha power 4 minus 5 into, divide with 4, okay, 5 into alpha square into within the brackets alpha square minus 1 greater than or equal to 0. So this can be understood as alpha power 4 minus 5 alpha power 4 plus 5 greater than or equal to 0. Alpha power 4 minus 5 alpha power 4 becomes 4 alpha power 4. 5 minus 4 alpha power 4 greater than or equal to 0. That implies you can write here 2 alpha square minus root 5 whole square. 2 alpha square whole square minus root 5 whole square lesser than or equal to 0. 2 alpha square minus 5 whole square lesser than or equal to 0. This can be understood as 2 alpha minus root 5 into 2 alpha plus root 5 lesser than or equal to 0. So alpha belongs to closed interval minus root 5 by 2 comma root 5 by 2. This is the range of the alpha. Minus root 5 by 2 comma root 5 by 2. Second option. Fourteenth question. If z into 2 minus 2 root 3 whole square, z into 2 minus 2 root 3I whole square. 2 into 2 minus 2 root 3 whole square is equal to I into root 3 plus I whole power 4. That implies argument of z is equal to dash. Argument of z is equal to I into root 3 plus I whole power 4 whole by this one taken this side, you can write 2 square common 1 minus I root 3 whole square 1 minus I root 3 whole square, that is equal to I into, I am converting the modulus amplitude form model, so multiply and divide with 2. So 2 into root 3 by 2 in plus I by 2 whole total power 4 plus 4 into here also you can write 2 into 1 by 2 minus I root 3 by 2. 2 into 1 by 2 minus I root 3 by 2 whole square total. That is equal to, so z is equal to, I am writing I into, this can be written as I power 4 into, this is cos pi by 6, cos pi by 6 plus I sin pi by 6 whole power 4, whole by, this is 4 into, this is 2 square. 2 square into this can be written as cos pi by 3 root 3 by 2 cos 30, this is of course 1 minus cos pi by 3 minus I sin pi by 3 whole square. Here 2 square into 4 becomes 16 and 2 power 4 16 get cancelled. I into, according to de Moivre theorem, this 4 becomes here, 4 will be coming in this place, 4 pi by 6 becomes 2 pi by 3. So cos 2 pi by 3 plus I sin 2 pi by 3 whole by, this can also understand as cos 2 pi by 3 minus I sin 2 pi by 3. I sin cos pi by 3 minus I sin 2 pi by 3. That is equal to I into cos 2 pi by 3. This can be written as cis of 2 pi by 3. Cis of 2 pi by 3 by cis of, this is minus 2 pi by 3. That is equal to I can be understand as cis of pi by 2, because cos 90 plus I sin 90 becomes only I into, according to formula cis theta 1 by cis theta 2 is equal to cis of theta 1 minus theta 2 by 2. So this is cis of 4 pi by 3. Now you can write as cis of theta 1 plus theta, cis of theta 1 into theta 2 becomes cis of theta 1 plus theta 2 by 2. So this is cis of pi by 2 plus 4 pi by 3. Take LCM here, cis of, this is 6. This is 3 pi plus this is 8 pi. That is equal to cis of 11 pi by 6. 11 pi by 6 meaning 330 degrees. 11 pi by 6 meaning 330 degrees. 330 degrees can be understood as 360 degrees minus 30. So alpha belongs to Q4, you can understand. Whenever alpha belongs to Q4, you need to write theta is equal to minus alpha in the polar form or modulus amplitude form. So theta is equal to, you can now understand, minus pi by 6. Because it is pi by 6 concept. Alpha is equal to pi by 6. So minus 11 pi by 6 is nothing but minus pi by 6. So answer is theta is equal to minus pi by 6. Second option. Fifteenth question. If Z lies on the circle, Z lies on the circle and modulus of Z minus 2i is equal to 2 root 2. Modulus of 2i is equal to 2 root 2. That implies argument of, so the value of argument of Z minus 2 by Z plus 2. The value of argument of Z minus 2 by Z plus 2. Given complex number as modulus of Z minus 2i is equal to 2 root 2. So let us write the modulus is x plus I by. So you can write here x plus I into y minus 2 over modulus is equal to 2 root 2. You can write this one as x square plus y minus 2 whole square is equal to 2 root 2 whole square. This is a circle. This is a circle with center. This is a circle with center 0, 2 and radius is root 2, not root 2, 2 root 2. Center 0, 2 and radius is 2 root 2. Draw a circle. Draw a circle like this. Center is 0, 2. So it is on the y-axis. And radius is 2 root 2. Draw a point like this. Put here A and here it is B. Put here 0, 2. Here P meaning Z. P be any point on the circle. Any point on the circle. PZ is a complex number. Now let us try to understand this is center C. From C to any point on the circle is called as radius. From center to any point on the circle. So this is 2 root 2. This is 2 root 2. This is also 2 root 2. Now try to understand like this. You draw like this. This is 0, 2. So this is 0, 0 origin. If left side meaning minus, right side meaning plus, this is on x-axis, you can understand. If you put here, this is 1, 0, simply I am verifying 1, 0, and this is minus 1, 0. Now you can understand the distance between AB is equal to, what is happening? AB is equal to 1 minus of minus 1 becomes 2. So AB is equal to 2. Now CA square. AB is equal to 2 students, it is okay. AB square is equal to 4. AB square is equal to 4. Next one, write like this is CA square plus CB square. CA square plus CB square meaning this is 1 plus 4 root 5. It is so, it is not 1. Maybe it is 2. Because 2 root 2 you should get, students. 2 root 2 you should get. So 2 comma 0 minus 2 comma 0. 2 square plus 2 square becomes 4 plus 4, 8. 8 means 2 root 2. Okay, root. So CA square plus CB square. Here AB square is not 4. 2 plus 2 whole square. 4 square means 16. So CA square plus CB square meaning here 4 plus 4, 8. Okay, 8 plus 8 it is equal to 16. So we have proved that CA square plus CB square is equal to AB square. So what is happening? CA square plus CB square is equal to AB square, meaning is that triangle ABC is right angle triangle and ACB is equal to 90 degrees. Pi by 2. Of course we given student z minus 2 by z plus 2. That meaning is here minus 2 and plus 2. Okay. Now you need to calculate, find. You should calculate the argument of. You should calculate the argument of z minus 2 by z plus 2. So from here like this. Z minus 2 this is and z plus 2 this is. Whenever ACB is equal to pi by 2, you know, you need to calculate now BPA. Angle BPA is equal to twice of this angle. Of course, angle in semicircle it is pi by 2. So the angle, the argument is pi by 2 here. Pi by 2 is the correct answer. Now 16th question. Modulus of modulus of Z1 by Z2. Modulus of Z1 by Z2 is equal to 1 and argument of modulus of Z1 by Z2 equal to 1 and argument of Z1 is equal to argument of Z1 Z2 equal to 0. Then according to option, what is the value? Given, I am writing. Given value modulus of Z1 by Z2. Modulus of Z1 by Z2 is equal to 1. That implies. We know the property of modulus of Z1 by Z2 is equal to separate modulus of Z1 by separate modulus of Z2. So you can write here modulus of Z1 is equal to modulus of Z2. According to modulus amplitude form, we can understand as Z1 is equal to R1 cis theta 1 and Z2 is equal to R2 cis theta 2. Like this we can write R1 cis theta 1 and R2 cis theta 2. That implies whenever modulus of Z1 is equal to modulus of Z2, you can understand R1 into root of cos square theta 1 plus sin square theta 1 is equal to R2 into root of cos square theta 2 plus sin square theta 2. Cos square theta 1 plus sin square theta 1 equal to 1 and cos square theta plus sin square theta is equal to 1. Therefore, you can understand that since modulus Z1 is equal to modulus Z2, you can understand here R1 is equal to R2. Keep aside. Now, given value I am writing. Argument of Z1 into Z2 is equal to 0 he given. Whenever argument of Z1 into Z2 he given, you can understand the formula argument of Z1 into Z2 is equal to argument of Z1 plus argument of Z2. So what is the argument of Z1? We thought it one as a theta 1 and this is as theta 2. So theta 1 plus theta 2 is equal to 0. Theta 1 plus theta 2 is equal to 0. Then you can understand theta 2 is equal to minus theta 1. Theta 2 is equal to minus theta 1. Therefore, Z1 is equal to, you can write as R1 into cos theta 1 plus I sin theta 1. And Z2 you can write as R1 into cos of minus theta 1 plus I sin of minus theta 1. This is the primary step. Because Z2 is equal to R2 into cos theta 2 plus I sin theta 2. Whenever theta 2 is equal to minus theta 1, you can write like this. Therefore, what we are getting, Z2 is equal to, write students like this, R1 into, Z2 is equal to R1 into cos theta 1 minus I sin theta 1. Therefore, we got the value as Z2 is equal to Z1 bar. This is the value. Z2 is equal to Z1 bar, because bar means conjugate complex number. Z2 is equal to Z1 bar we got. But option is not there. Z2 is equal to Z1 bar. It is a question, it is an option is there in another book you can find it. Now let us verify. Verify second option for this question. Verify second option. So what is the second option? Modulus of Z2 square. Modulus of Z2 square is equal to Z1 dot Z2. Z1 dot Z2. Let us calculate RHS for this one. So RHS meaning here Z1 dot Z2. So what is Z1 here? Simply you write Z1. So Z1. What is Z2? You can write here Z1 bar. Everyone know that Z dot Z bar is equal to Z square. So Z1 bar becomes Z1 square. Z1 square. Of course we know that Z1 is equal to, now you can apply Z1 square for modulus. So Z1 square, of course Z1, if you take modulus, so that implies you can write mod Z1 is equal to Z2, mod Z1 is equal to Z2 we have written. So Z1 Z2 meaning is modulus of Z1 square. Modulus of Z1 and modulus of Z2 are same, that is why Z1 Z2 is equal to modulus of Z2 square we can write here. In the concept we have completed 17th question and 18th question also. Now let us going to discuss about 19th question. The triangle with vertices. Let us draw the triangle. The triangle with vertices P, Z1, Q, P, Z1, Q, Z2, or 1 minus I into Z1 plus I Z2. 1 minus I into Z1 plus I Z2. Which type of triangle? We know that the distance between two complex numbers is modulus of Z1 minus Z2. Modulus of Z1 minus Z2 is the distance between two complex numbers PQ here. Now PQ we had written modulus of Z1 minus Z2. QR. So modulus of QR is write like this: 1 minus I into Z1. 1 minus I into Z1 plus I Z2 minus Z2. So I minus 1 take common and write like this Z2. Over modulus you should put. So you can understand 1 minus I you can take common along with modulus. So again you should write like this. Whenever I minus 1 is there, 1 minus I you have taken common. 1 minus I into modulus of Z1 minus Z2. 1 minus I modulus is root 2 into modulus of Z1 minus Z2. This is the QR over modulus. Keep aside. Now RP or PR. RP is equal to, you can understand 1 minus I into Z1 minus Z1. So 1 minus I minus 1 into Z1 plus I Z2 plus I Z2. 1 get cancelled. So I you take common. If you are taking common I, minus you take common along with the modulus, you will be getting as modulus of Z1 minus Z2. Of course, mod I means that is equal to simply 1. So whenever it is simply 1, you can write this is a modulus of Z1 minus Z2. Now, observing these two values, you can understand that modulus of QR square is equal to modulus of PQ square plus modulus of PR square. modulus of PQ square plus modulus of PR square. Modulus of PQ we got as simply Z1 minus Z2 and modulus of PR we got as simply Z1 minus Z2. This is, you can write Z1 minus Z2 over modulus. This is also we can write Z1 minus Z2 over modulus. Z1 minus Z2. This one we got as root 2 into modulus of Z1 minus Z2. So QR square is equal to PQ square plus PR square. So 2 into like this. Modulus of Z1 minus Z2 whole square plus modulus of Z1 minus Z2 is equal to 2 into modulus of Z1 minus Z2 whole square. This is also 2 into modulus of Z1 minus Z2 whole square. So we proved that, now we proved that modulus of QR square is equal to PQ square plus PR square. Therefore, triangle PQR is a right angled isosceles triangle. Right angled isosceles triangle. Okay students, we have completed some concept. Tomorrow, next class, 20th question is the complex number Z satisfying argument depends upon geometrical circle concept is there. Let us discuss about the sum in tomorrow class.